All right. In this particular video, we want to talk about the way to find constant term in a binomial expansion. So, of course, we have done several videos on binomial expansion, but there is a particular question that is always being administered to students in examinations, which is a question of this form, where you'll be told to find the constant term in a binomial expansion. Now, the truth is, you first need to understand what is the subject constant term. What does it really mean? So, if you have a binomial expansion, take for instance, you have a simple binomial expansion of 1 plus 2x raised to power 2. Of course, if you decide to expand this would give you a value of 1 square plus 4x plus 4x squared. All right. So this is what you have when you expand this particular expression. But to understand, of course, if you simplify this, you'll be having 1 plus 4x plus 4x squared. Now, for you to have understanding of what the term constant term actually signify, what you have to do is to go on to look for any, of course, this is the first term, this is the second term, this is the third term. So you want to look for that particular term that is void of any variable. And variable in mathematics are placeholders. That's when you have alphabets majorly being used to represent variables. So in this particular expression, we have x here is a variable and we have x squared also being a variable. They are like placeholders. So they are variables because they vary based on whatever the input is. All right. So if you want to understand constant term, all you need to look for is that term that doesn't have any particular variable close to it. So looking at what you have here, this has a variable, this has a variable. This is the only term here which is void of a variable. So if imagine you were told to find a question, you were told to find a constant term in this particular question, the value of the constant term will be 1. So in the same vein, that's exactly what you need to find for this expression. So you're told to find the constant term when you're dealing with 3x minus 2 raised to the power of 10. Now, in solving this, of course, you can see in this particular question I solved here, we expanded the whole expression. But in this question we have, if you decide to expand 3x minus 2 raised to the power 10, that will be very long. You can try it, it will be very, very long because you'll be having 11 different terms. Now that would actually not be a good use of your time. So you have to look for a more technical way, simpler way to solve questions like this. This is what I want to show you in this particular video. So if you have a question like this, what you simply have to do is, again, you would act like as if you were going to expand this 3x minus 2 rather raised to the power of 10. So you're going to act like you're going to expand this, but you would not make use of the k. You will not make use of k. So you'll be having 10 combination k. This is based on binomial theorem. 3x raised to the power of 10 minus k minus 2 raised to the power of k. All right. So now this is the first step while trying to find a constant term. So I would advise you can split this up, and try when you have a situation like this, you can split it up so that you'll be having 10 combination k, 3 raised to the power 10 minus k, and then x raised to the power 10 minus k, then minus 2 raised to the power k. All right, you can leave the bracket out or use the bracket depending on what you prefer. Now the next thing to ask yourself is, for you to have a constant term, even though I told you earlier that a constant term is void of a variable, but the truth is there is a way of expressing this. If I wanted to express this in a different way, I could express it like this: 1x raised to the power 0 plus 4x plus 4x squared. This is actually very correct because I'm sure you know that anything raised to the power of 0 is 1. So this will obviously still give you the same value. So all I'm trying to bring out from this is for you to understand that every constant term in a binomial expansion is always having x raised to the power of 0. The variable will be raised to the power of 0. So you will use this understanding to find a way to get the constant term without needing to expand the whole expression. So what you have to do here is simply ask yourself, for you to have x raised to the power 0, of course you'll be getting a constant term. Whatever has x raised to the power 0 is the constant term. Let me say that one more time. You can establish that as a theorem. Whatever in your expression has x raised to the power of 0 is your constant term. So you want to then go on to ask yourself, what will be the value of k that will make this particular expression of x raised to the power 10 minus k become x raised to the power 0? So for you to have x raised to the power 0, obviously your k has to be 10. Because if your k is 10, then you'll be having x raised to the power 10 minus 10. And when you have x raised to the power 10 minus 10, that will be x raised to the power 0. So obviously this means that for me to have my constant term, my k has to be equal to 0. So what I have to do next is to go on to solve for when k is equal to 0. So I'll be having 10 combination 0, 3 raised to the power 10 minus 0, which is 3 raised to the power 10. Then I have 10 minus 10. Then I have x raised to the power 10 minus 10, then minus 2 raised to the power 10. Of course, we should put this in a bracket so that you can understand it better. So if you go on to solve this, you can see we'll be having 10 combination 0, which will give me a value of 1. Sorry, it's not supposed to be 10. K was actually 10, so this is supposed to be 10 combination 10, which gives me a value of 1. 3 raised to the power 10 minus 10, that's 3 raised to the power 0. That gives me a value of 1. This is x raised to the power 10 minus 10, that's x raised to the power 0. That gives me a value of 1 also. And then we are left with minus 2 raised to the power of 10. If you press this on a calculator, multiplying it by 1, you will get a value of 1024. Obviously, this is the constant term in the binomial expansion. All right, let's try a different question, looking more technical at this point. So let's see how to find a constant term in this particular binomial expansion. So if we're deciding to expand this completely, of course you understand this is raised to the power of 18, you will spend a lot of time trying to find a constant term. So it's not worth it. What you have to do is to look for a quicker way, which is what I explained in using the last example. So we have to look for a place where we are getting our x raised to the power of 0, which is what will give me my constant term. So wherever x is raised to the power of 0 will be the value for my constant term. So the first step is for us to decide, we're going to act like we want to expand this normally, but we will miss out the k. We will not include any k value. So we'll be having 18 combination k. 18 combination k. Let me write this 18 well. And of course, this is based on what I'm doing here is the theory of binomial expansion. 1 over x raised to the power 2, the first term raised to the power 18 minus k, and then minus x raised to the power of k. This is on the basis of binomial expansion. This is the first step. So if we were going to expand this completely, obviously we're supposed to go on to be fixing our value of k ranging from 0 up until 18. But we're not going to be doing that. What we're going to do next is we're going to act like we're looking for what should produce x raised to the power 0. What should be my k value that will give me the value of x raised to the power 0? So what we have to do now, of course, to ease up this work is we have to, let's try and, this is 1 over x raised to the power 2. Let's make it simpler. So we have 18 combination k. Let's change this to x raised to the power minus 2 raised to the power 18 minus k. Then we have minus x raised to the power k. We're just trying to simplify the work so that we can get more clarity, because now we don't have one other thing that makes this work quite technical is that we don't have just one place where x is existing. So for us to get our value of x raised to power 0, we have to consider the multiplication of both x's. So that's where we must do that first before being able to get our final answer. So if you look at this, what we have here, I don't like that this minus is here. So what I'm going to do is I'm going to uh, get this minus out from here, because uh, it's 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 possible to do that, because obviously if I bring the minus here, that means if I just bring it here, if I bring it here, it's still going to be the same thing. I'm not wrong doing this mathematically. Just this step is to ease up your work. It's not wrong mathematically to do this, because in the end this minus will still affect everything. So me shifting the minus here doesn't. Don't forget, all these things you are seeing here, they are all one term. So it's not like a case where it's a different term, then you are removing the minus. It's still the same term. So if you put it here or you put it here, this minus still affects everything. All right. Now I'm looking at a more easier process now, because I can see I have x here, I have x here. So you know what I'm going to do next? I'm going to use my concept of indices. So the concept of indices, this is what I'm going to do. Of course, this is minus 18 combination k. Then I have x raised to power minus 36 plus 2k. Of course, that's opening the bracket. Then I have x raised to power k. So this is what I'm going to do next. This is the question I'm going to ask myself next. Don't forget, my interest is in seeing how to produce x raised to power 0. This is my interest. I want to see what value of k, that means what will be k, that will produce x raised to power 0. So I can see k here, I can see k here. So what do I have to fix in as k? That if I fix in that value as k here, it will, when I multiply these two together, I'll be getting x raised to power 0. Now you don't have to sweat so hard on that. It's not something you have to be permutating or looking for, trying different values. You don't have to do that. Just make use of your understanding of indices, and this is it. You're looking for this. This is the argument you are trying to solve. Now minus x raised to power minus 36 plus 2k times, let's just use a dot here because of hex being having a semblance with k, with multiplication sign. So look at what we have here. I want to say, if I multiply these two things together, I want to say this is the argument I want to solve. So look at this. I'm saying, okay, I have this and this. Of course, what we're looking for is what can we fix as our k to produce x raised to power 0. So I use my understanding of law of indices and I say, okay, if I multiply these two together, I want to arrive at x raised to power 0. So I want to bring these two together to achieve this. So obviously, in trying to solve this now, I will be getting the value of k that will produce 0. So this step right here is just for me to be able to get that value of k. So what we do next now is applying the law of indices. I'm sure you understand that when you have a question like this, you can bring these two expression to one, and that's by adding their power. So I can change this to, so this can be seen as of course this will be brought to just one single expression. That will be minus 36 plus 2k. Then based on the fact that we're multiplying, we have plus k. All right, based on the law of indices. Now this is the final thing we're trying to arrive at. We want to see how this can result to this. So from trying to solve this argument, we'll get the value of k that produces x raised to power 0. So as per the law of indices also, I'm sure you recognize that in a case like this, the law of indices permits you to cancel out the x's, and then we are able to arrive at minus 36 plus, in this case, this is plus 3k equals to 0. From here we have that 3k is equals to 36. And here we can see that our k will be equals to 36 over 3. That will give me a value of 12. So this implies that what we just said now is, at this particular instance, if I fix in my value of k as 12, which of course, if you are good in permutating, it is very possible you could have been able to arrive at that without having to make use of these other processes, but that will take your time, and probably only the very smart ones will be able to arrive at the value of k being 12. But a more surer and simpler way is to just go on to follow the process I just explained. So from here now, this means if I fix in my value of k as 12, I would arrive at my final expression of x being raised to the power of 0. So you can go on to try this out on your own. You can go on to try and fix 12 in here and see what happens. So if you fix 12 inside the original expression, even when you had minus here, when you had your minus here, if you fix in 12 there, one thing you would have is, because don't forget this was the original expression, what I just wrote was the original expression. It was while we were solving, I moved the minus out. So if you go on to fix in your 12 right here, what you're going to find is x raised to the power minus 2. 18 minus 12 will give you a value of, so 18 minus 12, that will be 6, just to show you guys how this works. So that will be 6, then multiply by, of course, minus x raised to the power 12. The minus will go because of the 12, because any minus raised to an even number would always cancel out the minus. So we'll be having a final answer of x raised to the power 12. All right. Looking at this, we have x raised to the power minus 12 times x raised to the power 12. Then we have x raised to the power minus 12 plus 12. This will give me x raised to the power 0. So obviously, I can assume now that wherever I fix in k as 12, I will get my final answer to be x raised to the power 0. Now don't forget, this is not the final thing. We're looking for the constant term. This is just the process that gives us the constant term, which I told you that anything that has x raised to the power 0 is always a constant term. So now that we have gotten a value of k that produces x raised to the power 0, we can obviously fix in k in the entire expression. All right, so looking at this, you can see that if you fix in k as 12, we'll be having 18 combination 12. Then, of course, we have solved this whole thing to give us x raised to the power 0. X raised to the power 0. And x raised to the power 0 is going to be 1. So obviously, we'll be left with just 18 combination 12, which is exactly what we're looking for, because we actually define a constant term as that term that doesn't have any variable. So we are very fine with it not having x, because that was exactly the point we were trying to make. And if you go on to find 18 combination 12, you'll get a final value of 18564. All right, so this is the final answer for this particular question, and you have saved yourself so much time. Instead of expanding the whole thing, you have been able to arrive at the final answer without wasting much time. So let me give you this exercise quickly. All right, I would love you to make an attempt to this particular question. Find a constant term in the following binomial expansion. Now, I don't expect you to go on with expanding the entirety of this expression. I prefer you make use of the method I just explained in the last two examples. All right, guys, this is going to be the end for this video. Thank you for joining. Bye-bye.